So our next chapter is hydrochloric acid. We are going to learn about its laboratory preparation, various reactions involving it, and also certain important properties about it. So first of all, coming to the laboratory preparation of hydrochloric acid, this reaction which I have written is already known to you. You have studied about this in the chapter acid, bases and salts. So most of the things that you will learn in this chapter is from the chapter acid, bases and salts. So as you can see, the apparatus used for the laboratory preparation is quite a complicated one. In a round bottom flask, we have taken a dilute solution of sodium chloride, or we can also take normal sodium chloride, and then we are pouring concentrated sulfuric acid using a thistle funnel. So this structure is known as a thistle funnel, and we will heat it. So two temperatures can be used. We will learn about it, but first let's see the apparatus nicely. So whatever HCl will be produced, it is coming out of the second tube. As you can see, the second tube which is not touching the liquid, from that HCl is coming out. HCl which will be formed in this reaction is a gas, not the normal hydrochloric acid we generally see in the laboratory. It is not liquid in this case. First we will get gaseous HCl, and then we will convert it into liquid HCl. So the HCl which is formed, the gas which is formed is not pure. It has water droplets and other impurities. So it is again passed through concentrated sulfuric acid. Just see the second container. Again it contains sulfuric acid. So sulfuric acid is used in this case to remove any water droplets, any water vapor. Now the HCl which is coming out from the second tube now, so that is free from water, and now that is collected by the upward displacement of air. That means air will move upwards, and and the hydrogen chloride gas will take its place. Why? Because hydrogen chloride is heavier than air. So air is moving upward and hydrogen chloride gas is moving downwards. Just like if you pour oil on water, oil floats on the surface because oil is lighter. In this case, similarly, since hydrogen chloride gas is heavier, it will settle at the bottom, and the air which was already present in the test tube or in the flask, that will be moving upward. So the reaction for this is NaCl plus H2SO4. If the temperature is less than 200 degrees Celsius, we will get NaHSO4 and HCl gas. But if the temperature is above 200 degrees Celsius, we will get Na2SO4 and HCl. Preferably the first reaction is used. We will learn why. But first of all, let's learn why we have used sodium chloride only, and why we are not using any other gas. Why just sulfuric acid is used. You have studied in the chapter acid, bases and salts that sulfuric acid is a non-volatile acid. It doesn't evaporate easily. This is one of the reasons why sulfuric acid is used. Another reason is nitric acid is very reactive. It shows different types of reaction. It does not react normally like other acids. So nitric acid is not preferred. Also, sodium chloride is used because sodium chloride is cheaply available, and we want to prepare HCl gas using the least expensive method. That's why NaCl is used, and this is the reason why sulfuric acid is also used. Next, how do we purify HCl? Like I told you, in order to remove water vapor, we use concentrated sulfuric acid which was present in the two-way flask, the second flask in the figure. We don't use any other drying agents. We could have used phosphorus pentoxide, or we could have used quicklime also, but we don't use these because they react with hydrogen chloride gas. Only concentrated sulfuric acid is unreactive, so we are using that. Next, talking about the collection of hydrogen chloride, I told you it will move downwards because it is heavier than air, and also it is not collected over water because it will readily mix with water and the reaction is comparatively explosive. So it is not collected over water because of its high solubility, and also it is collected by the upward displacement of air. The air will move upward, and hydrogen chloride gas being heavier, it will take its place. It will move downwards. How can we understand that hydrogen chloride gas has been formed? If we take a glass rod dipped in ammonium hydroxide NH4OH, we will get white fumes of NH4Cl. You can see the reaction here. If we bring a rod dipped in ammonium hydroxide near the mouth of the flask where we have produced HCl, NH4Cl is produced, which will give out white fumes. Seeing these white fumes, we can easily identify that yes, this is hydrogen chloride gas. Even when hydrogen chloride gas is exposed to moist air which contains water vapor, it will again show white fumes. So using these white fumes, we can easily understand that yes, hydrogen chloride is the gas which has been formed. So you will see and observe these reactions, and you will also do these reactions in class 11. Now talking about certain precautions which we have to follow while preparing the gas in the laboratory. First of all, the lower end of the thistle funnel must be dipped in concentrated sulfuric acid. You can see in the figure here that the lower end is dipped in concentrated sulfuric acid. Yes, this is a very important requirement. Next, the delivery tube should be dipped in the drying agent, that is concentrated H2SO4. So the second tube is also dipped in concentrated H2SO4. So why are these dipped? So that any gas will not escape through that tube. Whatever gas will be formed, it will escape only through the second tubes, not through the first tube. That's why the first tubes are both dipped in the solution. Next, temperature is maintained at nearly 200 degrees Celsius or comparatively lesser. I told you it is more preferable. Why? Because the apparatus is made up of glass. So if we use a high temperature, the glass might crack. Also, a lot of fuel is wasted because you have to attain a huge temperature. Also, the sodium sulfate which is formed in this reaction, it is very sticky. It sticks to the glass surface and it is very difficult to remove. So owing to these problems, we try to maintain the temperature lower than 200 degrees Celsius. So this is all about the laboratory preparation of hydrochloric acid. Next, talking about certain important properties of hydrochloric acid or hydrogen chloride gas rather. So we have already studied that it has a very high solubility in water, and also it is heavier than air. So we will just see how we can prove this in the laboratory. Experiment to demonstrate density, or that hydrogen chloride gas is heavier than air. So what has been done, we have taken a flask, and inside the flask we have kept a burning candle, and we have taken another flask which contains hydrogen chloride gas. Although it is colorless, but we can do this experiment. As soon as hydrogen chloride gas is prepared, we can keep it in a flask and close it so that it remains inside. So what we have done, we have poured the HCl gas into the flask containing the burning candle. We cannot see it obviously because it is colorless, but we will do as such as if we are pouring. So what we will observe, that the candle will cease to burn. The candle will stop burning. Why? What happens? The candle was burning because of the air which was present in the flask initially. But as soon as we are pouring hydrogen chloride gas, since hydrogen chloride gas is heavier, it will remove water, it will remove air and it will take its place. So hydrogen chloride gas cannot allow the flame to keep burning. So the flame will be extinguished. And from here we can understand that yes, hydrogen chloride gas is heavier. The air is getting removed and hydrogen chloride gas is taking its place. Next, talking about the solubility of hydrogen chloride gas. This is a very famous and important experiment which is called the fountain experiment. Observe it very closely. Take a dry round bottom flask filled with dry hydrogen chloride gas. Arrange the apparatus as shown. So as you can see, we have taken a round bottom flask in an inverted position and it is filled with hydrogen chloride gas, and at the bottom we have a blue litmus solution in a beaker, and we have connected a long jet tube because it will act as a jet. It will allow the water to the litmus solution to move into. So that's why it is known as jet tube. So we have connected this jet tube into the round bottom flask, and it is also touching the blue litmus solution. So now what happens? Press the dropper. We have a dropper over here. So as soon as we press the dropper, there is a creation, you can see there is a creation of vacuum inside, and whenever there is a creation of vacuum inside, there will be a suction. Just like we drink juice using a straw, we have to pull it with our lips, with the movement of our lips. Similarly, as soon as we press the dropper, the same observation happens. It is seen that blue litmus solution enters the jet tube with a great force. So as soon as you press the dropper, what happens? The solution, the blue litmus solution will suddenly move into the round bottom flask. So since the round bottom flask already had hydrogen chloride gas which is acidic in nature, so what happens? We have studied in acid, bases and salts. that acids, when are treated with blue litmus solution, it will turn red. So this blue litmus solution, when it enters into the round bottom flask, the blue litmus solution suddenly turns into red, and the fountain, it will be like a fountain. It will actually look like as if water is gushing out. So that fountain will be a red fountain. It will be a reddish colored fountain. So this is the fountain experiment. So from here we saw one thing, that hydrogen chloride gas is actually like an acid. It will behave like an acid because it is turning blue litmus red. Also we saw one more thing, that as soon as the litmus solution was moving into the hydrogen chloride gas, it was readily dissolving in the water and it was producing the color change. So from here we can understand that yes, hydrogen chloride gas is soluble in water, highly soluble in water. As the water goes in the flask from the dropper, HCl gas present in the flask dissolves due to its high solubility, and because of the lowering of pressure, the pressure decreases and hence the fountain. It looks like a fountain. The blue litmus solution turns red due to the acidic nature of hydrogen chloride gas. Very important. Question can come, what is the color of the fountain observed when hydrogen chloride gas is used? So it will be red because hydrogen chloride gas is acidic in nature. Next is a very important method for preparation of hydrochloric acid from hydrogen chloride gas. So like I told you, in the laboratory preparation we are actually preparing hydrogen chloride gas, not the acid. So now how do we prepare the acid? Again, we cannot just simply mix water with it because it is a very explosive reaction. So we have to use a different arrangement. This arrangement is known as the funnel arrangement. As you can see in the figure, we have taken a beaker full of water and the funnel is connected to the tube in which hydrogen chloride gas is present. So whatever hydrogen chloride gas was formed in the laboratory preparation, that hydrogen chloride gas is now allowed to pass through a pipe or a tube, and which in turn is connected to a funnel. So what happens, the funnel is placed on top of this water. It is not completely dipped, it is just touching. So what happens, when hydrogen chloride gas comes in contact with water, since we just learned that hydrogen chloride gas is highly soluble in water in the fountain experiment, due to this excessive solubility, the water from the beaker will suddenly move into the funnel. It will be like a back suction, which is very much unique. Okay, so the water will move into the funnel. As you can see in the second part of the figure, the water has moved into the funnel. So whatever hydrogen chloride gas was there in the funnel at that moment, that is mixing with the water, and when it has been mixed, the water will again fall back into the beaker. The same process continues. The water is getting back sucked by the hydrogen chloride gas due to its high solubility, and after it has mixed completely, the water will fall back into the beaker. This process continues till the water in the beaker is now full of hydrogen chloride gas, and the water is not pure water anymore, it is actually hydrochloric acid. So why don't we just simply mix water with the gas? Why do we use this funnel experiment or this funnel apparatus? Let's see. The funnel arrangement prevents or minimizes the back suction of water. It provides a large surface area for absorption of HCl gas. So if we did not use the funnel, if we just used a normal pipe-like structure, the water would move into the actual apparatus through which we produced HCl gas. The initial experiment, if we wouldn't be using this funnel experiment, then it would be a huge mess, right? And also, since the funnel has a lot of surface area, so the hydrogen chloride gas can easily mix with the water and produce hydrochloric acid. So let me explain this once again. So what happens, this water is moving into this water is moving into the funnel, right, due to back suction, and in this funnel only the dissolving is occurring. The hydrochloric acid is being formed. Hydrogen chloride is mixing with that much water only. But if this funnel was not there, if there was just this long tube, what would have happened? The water would have been completely back sucked and it would have moved here. This would be a problem. Or it might also have happened that the water would move here. It would be so much filled that the water would now move into this. And you know, when water is added to any acid, it is a very, very exothermic reaction. So there would be a huge explosion. So for this reason, we use this funnel arrangement, so that only the water is moving up to this part, not beyond it. And in this funnel only, the water is mixing with the hydrogen chloride gas, and then again it is falling back into the beaker. Also sometimes what can happen, by any chance the water can move into the tube. In that case, what is done, therefore, in order to prevent any accident, instead of using a direct tube from the flask to the funnel, we use another beaker here, and then from that beaker we connect again, so that even if water is moving into this tube, it will fall into this empty beaker and not to the actual apparatus. So this is the main reason. Now let's see a few reactions based on hydrogen chloride gas or hydrochloric acid. So only these reactions you have to remember, none of the other things. So reaction with ammonia. Whenever ammonia NH3 reacts with HCl, we are getting NH4Cl, ammonium chloride. This is a known reaction to you. So two gases are reacting to form a solid. Next, reaction with metals, oxides, hydroxides, carbonates, sulfides and sulfides. This is also known to you from the chapter acid, bases and salts. So whenever a metal reacts with HCl, it will form a salt and hydrogen gas will be evolved. The first reaction is Zn plus HCl gives ZnCl2 and H2. H2 evolves and it gives effervescence. Similarly with oxides and hydroxides, since we have oxygen, it will not form hydrogen, it will form water. Salt will be formed obviously and water will be formed. So ZnO plus HCl will give you ZnCl2 plus H2O, and ZnOH whole twice plus HCl will give you ZnCl2 plus H2O. In both the cases H2O is formed. Next, if we talk about carbonates and bicarbonates, you know carbonate is there, therefore carbon dioxide will be released. Along with that, a salt and water will be formed. This is common. Similarly with sulfides and bisulfides, salt will be formed, water will be formed and sulfur dioxide will be produced. Along with that, if we use sulfide, what will happen? We will get salt, we will not get water in this case, we will just get hydrogen sulfide gas with a bad smell. So all these reactions are known to you from the chapter acid, bases and salts. Next, if we talk about silver nitrate and lead nitrate. So these are two nitrates which are very much essential to test for hydrogen chloride gas or hydrochloric acid. So what happens when AgNO3, silver nitrate, is treated with HCl, we are getting a precipitate of AgCl and we are getting HNO3, we are getting nitric acid. So this precipitate, both the precipitates are white in color. So using this white precipitate, we can identify that yes, the liquid provided to us is hydrochloric acid. Similarly, lead nitrate, PbNO3 whole twice, when it is treated with HCl, it is giving you PbCl2 and HNO3. Now talking about aqua regia, this is a completely new thing for you. So what is aqua regia? It is a mixture of 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid. It is actually a mixture. So it contains 3 parts of HCl and only 1 part of HNO3. The ratio is 3:1. So what does it form? HCl plus HNO3, it is giving you nitrosyl chloride, NOCl. It is giving you water and it is giving you nascent chlorine. Chlorine in its atomic form. It is not in the molecular form. Very important reaction. You will learn more about this in 11. So this is aqua regia. Question can be asked that what is aqua regia and how is it formed. Next, reaction of manganese dioxide with HCl. MnO2 plus HCl, it will only act in concentrated form. Very important reaction. All the other reactions can be done using either gaseous form or dilute form. But in this case, in aqua regia and in case of manganese dioxide, the HCl has to be concentrated. So we have to heat also, because even if you are using concentrated, heating is essential in this case. So what is formed? Manganese chloride is formed, H2O is formed and Cl2 is released. Very, very important reaction, very unique reaction. So these are the 3 products which are formed. So I would urge you all to kindly practice these reactions by writing. If you don't write, you will eventually end up forgetting this. So write and practice.